somewhere in a museum archive, or pressed behind glass in a display case, or photographed and uploaded to a database that almost nobody visits, there is a map. And on that map, there are rivers. That's not unusual. Maps have rivers, except these particular rivers don't exist anymore. They haven't existed for thousands of years, some of them possibly 12,000 years or more. And the question that should be keeping you up at night, the question that has quietly driven archaeologists and geographers into arguments that last decades, is this: how did whoever drew that map know they were there? That's the mystery. That's what this whole thing is about. Because here's the problem: rivers don't just vanish quietly. When a major river system disappears, it takes the landscape with it. The vegetation dies back. The animals that depended on it move or go extinct. The civilizations that built along its banks collapse or migrate. And crucially, the memory of it fades. Within a few generations, people who never saw the river simply don't know it existed. It becomes myth if you're lucky. It becomes nothing if you're not. So when you look at certain ancient maps and find what appear to be accurate depictions of river systems that dried up long before writing was invented, long before organized civilization as we understand it, long before anyone should have been making maps at all, you have to stop and ask a very uncomfortable question. What is going on? Now, before we go any further, we need to be honest about one word in our title, and that word is oldest. Because oldest map is one of those phrases that sounds simple until you actually try to define it. Are we talking about the oldest surviving physical object that functions as a map? Are we talking about the oldest known cartographic tradition, the earliest evidence that humans were spatially organizing geographic information in a way we'd recognize? Or are we talking about something stranger and harder to pin down, the oldest landscape memory encoded in a document, a story, a scratching on stone, that somehow preserved knowledge of a world that no longer exists? Those are three very different things, and the answer changes depending on which definition you use. The oldest surviving object that most scholars agree functions as a map is probably not what you'd expect. It doesn't look like a map. It doesn't have neat lines and labelled features. It looks like a rock with some marks on it. But those marks, when analysed carefully, appear to show terrain. Hills, valleys, paths between them. And the terrain matches landscape features that geologists can still identify today, even though the map itself is tens of thousands of years old. Then there are clay tablets. There are painted cave walls. There are astronomical alignments in ancient structures that some researchers argue encode geographic knowledge that shouldn't have been accessible to the people who built them. Each candidate for oldest map brings its own controversy, its own defenders, its own skeptics. We're going to look at several of them, but the one that started this whole conversation, the one that inspired the question we're chasing through this entire video, is a Babylonian clay tablet. Small enough to hold in one hand, old enough that the civilization that made it is long gone. And on it, sketched in cuneiform and lines pressed into clay, is what appears to be a map of the known world. And somewhere on that map, or in the geographic tradition it represents, are rivers. Rivers that match with uncomfortable precision, waterways that hydrologists and satellite imaging experts have only recently confirmed existed in the deep past. Waterways that dried up roughly 12,000 years ago, at the end of the last ice age, when the planet went through a climate transformation so dramatic that entire river systems ceased to flow, and entire regions that were once green became desert within a few thousand years. How does a Babylonian clay tablet know about rivers that vanished before Babylon existed? That's the question. And the honest answer, the one that careful researchers give when they're not being sensational, is that we don't fully know. There are theories, good ones actually, theories that don't require ancient aliens or lost civilizations or any of that. But they do require taking seriously the idea that human memory, transmitted through oral tradition and story and repeated observation of landscape features, can preserve geographic knowledge across timescales that feel almost impossible. Almost, but maybe not quite. We're going to work through all of it. The maps, the rivers, the science of finding waterways that disappeared millennia ago, the geology of why rivers vanish, the specific cases that have researchers genuinely divided, and what we can say with real confidence versus what remains genuinely open. No fake mysteries, no pretending we can't explain things when we can, but also no pretending the questions are simple when they aren't. Before we go there though, one thing. If you're listening to this on Spotify, first of all, thank you, and second, if you follow the show there, you get it completely ad-free and without any background music. Just the story, clean and uninterrupted. It helps keep this going, and there's a link in the description if you want to do that. It genuinely makes a difference, and I want to know where you are right now. Drop it in the comments. The city, the country, the time. Is it late where you are, lights off, trying to let this carry you somewhere? Or is it morning, and you're half awake with coffee going cold next to you? I read these. It's one of the stranger and better parts of doing this, watching the map of listeners fill in Berlin at sunrise, Auckland at midnight, someone in rural Montana who just drove home from a night shift. You're all here at once, and that's genuinely strange and good. All right, let's go back to the beginning, or as close to the beginning of maps as we can get, which turns out to be a lot further back than most people realise. So what actually counts as a map when you're talking about the ancient world? That sounds like a question with an obvious answer until you try to answer it. We tend to think of maps as objective documents, lines on a surface that correspond to real locations, drawn to approximate scale, oriented consistently, designed to help someone navigate from one place to another. That's a very specific and very modern idea of what a map is. And if you apply that standard to the ancient world, you eliminate almost everything. You're left with almost nothing, which tells you the standard is wrong, not the artifacts. What researchers who actually work in this field define as map-like artifacts is a much broader and more interesting category. It includes clay tablets with geographic sketches pressed into them, rock art that shows terrain features, water sources, paths between hunting grounds, painted cave walls where certain arrangements of marks seem to correspond to ridgelines and valleys, special diagrams carved into bone or stone that organise landscape features relative to each other without caring much about precise scale, and what some scholars call narrative maps, which aren't physical objects at all but oral descriptions of territory so detailed and so consistently transmitted that they function the same way a drawn map does, letting someone who has never been somewhere navigate it anyway. All of these things encode spatial information. All of them represent someone trying to organise geographic knowledge in a form that can be communicated and preserved. If you're willing to define map that way, then humans have been making maps for a very long time indeed. Tens of thousands of years. Possibly longer. But here's what complicates it. Early mapping almost never tried to be purely geographic. In the ancient world, maps mixed geography with cosmology, with politics, with religion, in ways that make it very difficult for modern researchers to separate the factual spatial content from everything else layered on top of it. A Babylonian map doesn't just show you where places are. It shows you where places stand in relation to the divine order of the universe, where power is legitimate, where chaos begins, where the known world ends and the unknowable begins. The rivers on that map aren't just rivers, they're also theological statements about the nature of reality. This matters because it means you can't evaluate ancient maps the way you'd evaluate a modern one. You can't just look at a feature and say that represents this river. You have to ask whether the feature is there because someone observed it and recorded it, or because it was cosmologically required to be there, or because it served a political purpose, or because it was inherited from an older tradition without anyone really knowing what it originally referred to. Those are four very different answers, and they have completely different implications for what the map actually tells us. Which brings us to the criteria that serious researchers use when evaluating claims about ancient maps. There are four main ones: date, which means not just when the physical object was made, but when the information encoded in it was first generated, which is often much harder to determine. Provenance, meaning where it came from, under what circumstances it was found, and whether that context is reliable. Purpose, meaning what the people who made it were trying to do, since a religious diagram and a practical navigation tool made by the same civilization look nothing alike and shouldn't be evaluated the same way. And legibility, meaning whether modern researchers can actually decode what the marks represent, and whether multiple independent analysts agree on that decoding, or whether the interpretation depends heavily on who's doing the looking. Applying those four criteria is what separates careful scholarship from sensationalism. And this is where a lot of ancient map claims start to fall apart. An object might be genuinely old, but have unclear provenance. It might have clear provenance, but uncertain purpose. It might seem legible until you realize two researchers looking at the same marks see completely different things. There's also a distinction that matters enormously in the specific conversation we're having about rivers. There's a real difference between a map that depicts routes and regions and a map that depicts precise river courses. Most ancient spatial documents do the first thing. They tell you roughly where places are relative to each other, which direction water lies from a given mountain, how far a journey takes, which territories belong to which groups. That kind of geographic knowledge is robust and durable. It can survive thousands of years of oral transmission without losing its essential accuracy, because relative positions don't change much even when landscapes do. But depicting the precise course of a specific river system, its bends, its tributaries, its connections to other waterways, that's a much more specific claim that requires either direct observation or an extremely faithful transmission of someone else's observation. And when a river system has been gone for 12,000 years, the question of how that observation could possibly have survived becomes very hard to answer. That's the question that modern researchers try to address using tools that ancient mapmakers never had. Satellite radar imaging that penetrates desert sand to find the ghost outlines of riverbeds below the surface. Sediment cores that reveal ancient flood deposits and water chemistry from periods long before human civilization. Isotopic analysis of ancient organic material that can tell you when a particular landscape last held water and roughly how much. When researchers take a geographic claim encoded in an ancient document and test it against what the physical landscape actually shows underground, that's when things get genuinely interesting. That's when you find out whether an old map is remembering something real, which is exactly the kind of test that the most contested ancient maps have been put through. And the results, in several specific cases, have surprised people who expected them to be simple. If you ask most people what the oldest map in the world is, the answer you'll usually get is simple: the Babylonian World Map. A clay tablet about the size of your hand, drawn around 600 BCE, showing a circular world surrounded by cosmic waters. It appears in textbooks, in documentaries, in conspiracy videos. It's iconic, and that answer is also wrong, or at least incomplete in a way that matters a lot for the story we're telling. Because there isn't one oldest map. There's a spectrum of candidates stretching back thousands of years before Babylon, and they're doing very different things. Take that Babylonian World Map first, since it's the celebrity in the room. What it actually shows is a disk with Babylon at the centre, the Euphrates cutting through it, a few cities and regions marked around the edges, and then a ring labelled as the Bitter River, or Cosmic Ocean, beyond which are triangular regions that may represent distant, mysterious lands or mythic zones. It looks like a world map because it's labelled Map of the World in cuneiform. It uses symbols that clearly correspond to real places: Babylon, Assyria, the Euphrates. There's spatial thinking here, but it's not a topographic map. It doesn't care about scale. It doesn't try to give you an accurate coastline. The rivers are not mapped as they actually flow. They're schematic lines organizing the cosmos around a sacred center. In other words, it's more like a diagram of how the Babylonians thought the universe was structured than a Google Earth screenshot baked in clay. Useful but cosmological first, geographic second. If you go slightly later in time, to the Greek world, you get another kind of world map. Think of Anaximander in the 6th century BCE, who is credited with drawing one of the earliest Greek maps of the inhabited world, and Hecataeus, who refined it. We don't have their actual maps, but we have descriptions. They imagined the oikoumene, the inhabited world, as a disk or oval surrounded by ocean, with Europe, Asia and Libya, Africa, arranged around the Mediterranean like slices. Again, that sounds like cartography in a familiar sense. There's an attempt to lay out continents, to put seas and rivers in relation to each other. But most of what survives is textual. Reconstructions are based on later authors quoting and paraphrasing them. Whenever you see a nice clean Anaximander map in a book or online, remember that's a modern illustration of an ancient idea, not the original artifact. And Greek maps have their own blend of observation and ideology. Herodotus in the 5th century BCE openly mocks the simplistic circular map tradition and insists that real geography is more complicated. That tells you that even by then, scholars understood a key point we still struggle with today. A world map is always an argument about how the world is, not just a passive record of what it looks like. Egypt gives us yet another flavour. One of the oldest reasonably clear cartographic documents from Egypt is the so-called Turin Papyrus Map, usually dated to around 1150 BCE. It shows a stretch of desert east of the Nile, wadis, hills, a gold mining area, and a route through them. It has labels for quarries and annotations that seem to describe types of stone. Unlike the Babylonian world disk, this thing is practical. It's not a cosmic diagram, it's more like a mining engineer's sketch. The orientation is odd by our standards, and the scale isn't perfectly uniform, but studies suggest the shapes of the wadis and hills do correspond in a recognizable way to the actual landscape. It's almost a topographic map, but of a tiny region, not the world. So you can already see there's no straight line from first map to map of everything. Local functional maps appear alongside symbolic world diagrams, and they're doing different jobs. And then there are the really old contenders, the ones that don't look like maps at all unless someone points it out. For example, simple scratch diagrams on clay tablets from Mesopotamia, centuries older than the Babylonian World Map, that show fields, canals, and property boundaries. Some of these go back to the late 3rd millennium BCE. They're essentially cadastral plans: who owns which plot, where the irrigation channel runs, how the land is divided. They rarely get called the oldest map in popular media because they're not dramatic, and they definitely aren't showing the world. But they're more map-like in the strict sense than a lot of cosmic diagrams are. Go back further and things get even more ambiguous. There's a fragment from the city of Nippur, sometimes touted as a map, that might show part of a city layout with walls and canals. There are early Bronze Age artifacts from the Near East and Anatolia, where patterns of lines and shapes on clay or stone have been interpreted as town plans or river networks. The problem is, interpretations vary wildly. Turn the object 90 degrees and someone else sees something completely different, outside the Near East. Several Neolithic rock carvings and paintings in Europe have been called maps of villages, fields, or river systems. In Spain, the so-called Mapa de Abonts, engraved on a stone from a cave in Navarra, and often dated to around 13,000 to 14,000 years ago, has been proposed as a hunting map: rivers, paths, and animal locations. Some scholars find the geographic reading persuasive. Others think it's patterning, ritual symbolism, or something in between. That something in between is the problem. The older you go, the less clear the purpose. the harder it is to separate this is a stylized landscape from this is a cosmological pattern that just happens to look like a landscape if you squint. And the dating isn't always as secure as headlines make it sound. An artifact can be found in a layer dated to, say, 14,000 years ago. That gives you a maximum age for the object, but it doesn't guarantee the engraving itself was made at that exact time. It might have been reused, recarved, or moved. With papyri or clay tablets, you can sometimes cross-check the script style and historical references. With rock, all you often have is context and guesswork. There's another wrinkle. A world map doesn't mean what you think it does. When a Babylonian scribe draws the map of the world, they are not trying to chart every coastline and river on Earth. Their world is the culturally known and relevant space around Mesopotamia, embedded in a mythic ocean. The goal is to show order versus chaos, centre versus margins. Topographic accuracy is not the primary concern. By contrast, a tiny sketch of 3 wadis leading to a mine in the desert is not a world map at all, but it might tell you much more precisely what the terrain looks like if you're actually walking through it. So when people ask, what's the oldest map? They're usually blending together several different questions without realizing it. Oldest world diagram? Oldest city plan? Oldest property survey? Oldest landscape drawing that can be checked against real topography. Those do not all have the same answer. And that's crucial for a claim like, this map shows rivers that vanished 12,000 years ago. If we don't separate symbolic world pictures from genuine attempts at topographic representation, we can project anything we want onto ancient symbols and convince ourselves we've found evidence of lost civilizations. Before we decide that a particular ancient artifact is remembering real rivers that no longer exist, we have to be ruthless about what kind of map we're actually looking at. Is it cosmology with a few rivers sprinkled on top? Or is it cartography in the strict sense, an effort to encode real spatial relationships on a surface? That distinction is what we need to keep in mind when we finally come back to the Babylonian world map itself, and to the specific river problem that has made it the centerpiece of so many mystery claims. When you look at the Babylonian world map for the first time, it feels deceptively simple. A clay tablet about 12 by 8 centimeters. On it, a circle. Through that circle runs a vertical line. That line is the Euphrates. Near the middle of the circle, a little rectangle, Babylon. Around the circle's edge, a ring labelled in cuneiform as the Bitter River, often taken to mean the encircling cosmic ocean. Beyond that ring, little triangles poking outwards, each with short captions, region, where one must travel for X days, region where the sun is not seen, region where a great bird cannot reach. It's not subtle. The scribe is telling you, this is the world with a centre, with edges, with strange lands beyond. Inside the circle a few more labels. Some are very clear. Babylon, Assyria, Urartu. Others are broken, partially missing or ambiguous. Scholars have worked over these for more than a century, comparing sign forms, dialect and context to reconstruct what the captions probably said before the tablet cracked and the edges eroded. This is where the river problem begins. If you read the cuneiform carefully, there is exactly one major river explicitly named in the main disk, the Euphrates. It cuts through Babylon and runs roughly from the top of the circle to the bottom. That's it. The famous Tigris, the other great river of Mesopotamia, is not clearly labelled as a separate line on the surviving portions of the map. You can debate whether some faint broken markings to one side might be intended as the Tigris, but we're already leaving the safe ground of this sign definitely says X, and walking into this could be interpreted as. The geometry of the tablet adds another layer. The world is drawn as a neat circle. The Euphrates is drawn as a straight line through that circle. If you're expecting a geographically faithful plan of Mesopotamia, this will immediately feel off. The real Euphrates does not run like a ruler line through a perfect disk. But if you understand that, For a Babylonian scribe, the goal was to anchor a cosmic diagram on a familiar feature. It makes more sense. The Euphrates is not there to be measured. It's there to connect heaven, earth, and the underworld. It's an axis as much as a river. So how do scholars read this thing? They start from the text. At the top of the tablet is a heading that can be translated roughly as Map of the World. Around the circle are short inscriptions giving the names of regions: Assyria, Urartu, the land of Haban, various toponyms that can be tied with varying degrees of confidence to places we know from other Babylonian texts. The bitter river encircling the disk is identified in words. The triangular regions beyond it are each given brief notes like where a great flood rises, where a horned bull is seen, where the sun is not visible. These are not surveyor's notes, they are mythic and directional cues. To interpret layout, Assyriologists combine the inscriptions with what we know about Babylonian cosmology from other sources. Texts describing the 4 cardinal directions, lists of foreign lands, omens that associate particular stars or winds with specific regions of the earth. When the map puts Urartu in one place and Assyria in another, they ask, does that correspond, at least roughly, to where those lands were thought to lie relative to Babylon? The answer is, sort of. The broad pattern lines up. Babylon is central, Assyria is above it. Some western regions appear to the side that we'd call west. The triangles beyond the bitter river correspond to a conceptual outer ring of distant lands. But details are fuzzy, and the placement isn't consistent in scale or angle. It's a mental map, not a projection. Now about those extra rivers. If you look at high-resolution photos of the tablet, you'll see more than just the main vertical line of the Euphrates. There are faint lines, chips, stains, parts where the clay surface has flaked. In some reproductions, these artifacts of age and damage look like lighter or darker streaks. If you're predisposed to see waterways, those streaks start to look like branching rivers, deltas, or coastlines. In some drawings, early editors tried to clarify what they saw by tracing these lines. A secondary curved line here, a possible channel there. They were doing their best with poor lighting and damaged clay. Later scholars, and especially modern digital photographs, have shown that not all those supposed lines are intentional. Some are just cracks. Some are scratches that don't correspond to any incised design. Some cut across known cuneiform signs at odd angles. They're later damage, not part of the original composition. But the temptation to turn them into geography is strong. If you come to the tablet with the idea that it secretly preserves an ancient memory of a more complex river network, every random mark becomes potential evidence. A chipped area on one side of the disk can be filled in your imagination as a missing river mouth. An ambiguous mark near the bottom becomes a coastline. Before long you have discovered rivers that the tablet never actually depicted, even in the preserved intentional markings. There's room for projection. The Bitter River Ring. Is that a literal ocean? A stylized boundary? A floodplain? The little wedges that may represent marshes or canals, are they specific local features or generic symbols of watery places? Without a legend, you have to infer function from how Babylonian scribes used similar signs in other contexts. Some uses are clear, others are debatable. That's why professional discussions of the map are full of careful language, perhaps indicating, may represent, possibly to be identified with. When you read a technical article on it, you'll see a lot of hedging. Not because scholars are evasive, but because the artifact really is fragmentary and stylized. There are hard constraints what the cuneiform actually says, where incised lines clearly begin and end, and beyond that there's interpretation. So what can we reasonably expect from this tablet in terms of geographic accuracy? We can expect broad directional relationships that made sense to a late Babylonian scholar, Babylon in the middle, nearby powers around it, a surrounding ocean, mysterious lands beyond. We can expect the Euphrates to be in roughly the right place relative to Babylon, because that river literally ran past the city. We can even grant that some peripheral labels might be anchored loosely to the general understanding of where those lands lay in the real world. What we should not expect is centimetre-level fidelity to real coastlines, exact river courses, or precise distances. The circle is not a scaled projection. The Euphrates is not drawn with its meanders. The Bitter River is not the actual Persian Gulf traced correctly. The map compresses, distorts and idealizes space in order to tell a cosmological story, center versus periphery, order versus the unknown, land versus encircling water. That doesn't mean it's useless for geography. It means we have to treat it as a hybrid part myth, part memory, part schematic diagram. If you insist on reading every mark as a literal topographic feature, you will almost certainly overinterpret what's really there. And yet, that's exactly what happens when people claim this map shows rivers that vanished 12,000 years ago. They take a damaged, stylized, 2,600-year-old cosmic diagram and treat it like a satellite image. They see extra waterways where scholars see cracks and unknowns. They assume a level of precision the original scribe never aimed for. To understand why that's a problem, and why the vanished river claims are so dramatic, we need to look at what that 12,000-year figure actually refers to, and what it would mean for a 6th century BCE Babylonian tablet to be remembering landscapes from the end of the Ice Age. That's where we're headed next. 12,000 years ago is not just a long time. In geological terms, it's a hinge in Earth's recent history. Put your finger on a timeline at about 12,000 years before present, and you're basically touching the end of the last Ice Age. Glaciers that had sat on North America and Northern Europe for tens of thousands of years were in rapid retreat. Sea levels were racing upward, sometimes meters in a human lifetime along low coasts. The climate was wobbling out of the cold, wildly unstable Pleistocene, and into the relatively mild, more stable period we live in now, the Holocene. On land, that shift was brutal for rivers. A river is not a fixed object. It's an active system made of water, sediment, gravity, and time. When climate, sea level, or tectonics change, rivers respond, and they respond dramatically. Sea level drops during an ice age. Rivers carve deep valleys, racing toward the distant, lowered coastline, cutting canyons and incising their beds. Sea level rises quickly at the end of an ice age. The base level, the point they're ultimately flowing to, jumps upward. The lower stretches drowned, turning into estuaries and deltas. Sediment starts piling up instead of being flushed out to the deep ocean. Channels silt up, split, migrate sideways. Even without ice sheets and sea level swings, rivers are restless. They meander, swinging back and forth across their floodplains. They abandon old loops and cut new paths, leaving behind oxbow lakes that slowly fill with mud and disappear under fields and cities. Sometimes, especially in low-gradient alluvial plains like Mesopotamia, they do something even more radical. They jump. Geologists call it avulsion. Picture a river laying down its own levees as it floods year after year. Over time, the channel sits higher than the surrounding plain, perched on a ridge of its own making. Then one big flood overtops those levees in a slightly lower area, cuts a new channel, and suddenly most of the water is roaring off in a new direction. The old course is abandoned. It becomes a chain of marshes, then dry ground, then a faint, ghostly line visible only from the air or in satellite data. Tectonics adds another layer. If the ground tilts slowly over thousands of years, rivers will follow the tilt, abandoning former paths. If a region subsides, sinks under the weight of sediment, or due to deeper crustal movements, rivers may break up into multiple distributaries and inland basins, or drown beneath growing deltas. If uplift occurs, old riverbeds can be stranded high above current valley floors, preserved as terraces and hanging valleys. And then there's burial. Rivers are not just carved into rock. In many flat regions, they are carved into their own deposits. Once an old channel is abandoned, later floods and wind-blown dust can cover it with meters of new sediment. Over time, the ancient river becomes a paleocanal or paleoriver, a fossil riverbed, invisible at the surface, but still there in the subsurface as sand and gravel bodies, faint colour differences, or subtle variations in soil moisture. So, when someone says, "This ancient map shows rivers that vanished 12,000 years ago," they're invoking a world where ice sheets are melting rapidly, sea levels are climbing, coastlines are drowning and moving inland. Major river systems are reorganizing themselves on continental scales. That's not science fiction. We know these things happened. We can see the submerged river valleys on continental shelves today. We can drill into buried channels under modern deserts. We can trace ancient deltas far inland from today's coasts. The question is not whether rivers vanished or moved at the end of the Ice Age. They did. The question is, what would it take to argue that a Babylonian clay tablet from around the 6th century BCE is accurately depicting one of those lost 12,000-year-old landscapes? The answer is, you would need an extraordinary chain of evidence. At minimum, 3 things. First, you'd need a very clear, unambiguous depiction on the tablet itself. Not vague lines, not cracks, not ambiguous smudges, but an intentionally carved river system that can be confidently distinguished from decoration, damage, or generic symbolism. Ideally, you'd have inscriptions labelling those rivers in a way that can be tied to known or hypothesized paleorivers. Second, you'd need an independently reconstructed ancient river network, dated to around the end of the last ice age. That reconstruction would typically come from modern geoscience, satellite imagery, field mapping, sediment cores, radiocarbon dates, maybe even seismic surveys if you're dealing with buried channels offshore or under thick sediments. Third, you'd need a convincing match between the map and that reconstructed paleoriver system that cannot be reasonably explained as coincidence. That means the relative positions and orientations of the rivers line up. The branching patterns line up, key junctions, bends or terminations line up. And crucially, this match persists even when you account for the fact that ancient schematic maps distort scale and shape. If you can check all those boxes, you're in business. Then you get to ask the really wild question. How did Babylonian scholars preserve knowledge of a landscape that disappeared thousands of years before the rise of agriculture, writing, and the cities we associate with Mesopotamia? But we're nowhere near that threshold with the Babylonian World Map. Instead, we have to consider 3 much more mundane, but much more likely possibilities for the 12,000-year-old river's claim. Possibility 1. There is some real, very deep time memory embedded, not in the precise geometry of the map, but in myths, place names, or conceptual geography that the map is loosely echoing. Human oral traditions can sometimes preserve surprisingly old stories about floods, coastlines, and volcanoes. Some researchers argue that narratives of drowned lands or rivers that once flowed here in later cultures might faintly reflect post-glacial sea level rise. It's not impossible that over millennia, stories about shifting waterways in the broader Near East could have been mythologized and then given symbolic form in texts and diagrams. Possibility 2. The resemblance to 12,000-year-old river systems is largely coincidental. If you take a stylized circle with a few lines and triangles on it, and then overlay various reconstructed paleoriver networks from satellite data, you will eventually find one that looks kind of similar, especially if you're generous with rotation, scaling, and imagination. Human brains are pattern-finding machines, We see faces in clouds, animals in constellations, and ancient shorelines in coffee stains. The more vaguely drawn the ancient map, the easier it is to line it up with something else and declare a match. Possibility 3. Modern misreading. This is the one we saw forming in the previous section. Cracks, chips and discolorations on the clay tablet being traced as intentional lines. Stylized features, cosmic oceans, symbolic waterways, generic marsh symbols being treated as literal topographic details. Early hand-drawn reproductions being taken at face value, while better photos and modern readings are ignored. Once the story, this show's lost. Ice Age Rivers is out there. Confirmation bias does the rest. All three possibilities can coexist. You can have genuine long-term cultural memories of environmental change, coincidental visual echoes between simple shapes, and enthusiastic over-interpretation of damaged artifacts, all wrapped up in one viral claim. To sort them out, you have to move beyond the tablet and into the landscape itself. You need to know what the rivers actually looked like 12,000 years ago. That's where paleorivers come in. A paleoriver is simply a river system that no longer flows in the same way it once did. Its channels may be dry, diverted, submerged under the sea, or buried beneath younger sediments. But with the right tools, those ghost rivers can be mapped. Today, scientists detect paleorivers using a toolkit that would have seemed like magic to the Babylonians. Satellite imagery, especially infrared and radar, can pick up subtle differences in soil moisture and vegetation that trace old channels. Airborne LiDAR can strip away forests and buildings digitally, revealing hidden river terraces and abandoned meanders. Ground-penetrating radar, seismic reflection, and drilling can image buried sand bodies tens or hundreds of meters below the surface. Dating methods, radiocarbon, optically stimulated luminescence, even cosmogenic nuclides can put age brackets on when those channels were active. When you combine that data, you can reconstruct river networks as they looked at different times. 6,000 years ago, 12,000 years ago, 60,000 years ago. You can see entire deltas that no longer exist. You can map river valleys that are now 100 meters underwater on continental shelves. You can trace streams that once crossed what are now hyper-arid deserts. Only after you have those reconstructions on the table does it make sense to go back to an ancient map and ask, is there any plausible connection? Are we seeing deep memory, accidental similarity, or wishful thinking? In the next sections, we'll look at some of the places where paleorivers are most dramatic, the Sahara, Arabia, Mesopotamia, India, and ask how, if at all, they intersect with what ancient people drew and wrote. If you want to know whether an ancient map is picking up a real Ice Age river, you can't start with the map. You have to start with the river. That means asking a very simple, very unromantic question. Where did the water actually go? To answer it, modern researchers use tools that, from the perspective of a scribe scratching lines into clay, would look indistinguishable from sorcery. They let us see through clouds, through forests, even through sand and soil, and they turn ghost rivers into measurable, mappable objects. The first line of attack is orbit. Satellites don't just take pretty pictures. They record light far beyond what your eyes can see. Invisible light, a dry floodplain might look like any other expanse of farmland or desert. But shift into the infrared, and subtle differences jump out. Old river channels tend to hold a bit more moisture. Their sands and gravels drain differently than the surrounding clays. That changes how plants grow, slightly greener strips in a brown landscape, or bands where crops mature at a different rate than neighbouring fields. Multispectral and hyperspectral imagery slice the spectrum into many narrow bands, letting software tease out those differences. What looks like a flat plane to you resolves, for a computer, into a branching network of faint lines and lobes, the skeletal remains of rivers that once flowed there. Radar adds another layer, Unlike ordinary optical sensors, radar systems like those on the European Sentinel satellites or NASA's old shuttle radar topography mission send out radio waves that can penetrate clouds and, in dry deserts, even a little way into sand. The returning signal is sensitive to surface roughness and moisture. Old channels, filled with coarser sand and gravel, often give a different radar texture than fine-grained overbank deposits. The result is a ghostly, branching pattern cutting across dune fields and alluvial fans, paleochannels drawn not in ink but in microwave backscatter. Then there's LiDAR, light detection and ranging. Fire a laser from an aircraft thousands of times per second. Time how long the pulses take to return, and you can build an incredibly detailed 3D model of the ground surface. Crucially, LiDAR can digitally strip away vegetation and buildings. Under a forest canopy or a modern city, it can still see the underlying microtopography. A river that abandoned its course 5,000 or 50,000 years ago may have left behind a slightly lower swale, a subtle levee ridge, a half-erased meander scar. To the naked eye, standing on the ground, those features blur into the general lumpiness of the landscape. In a LiDAR-derived elevation model, they leap out, sinuous lines, concentric loops, delicate braids, all betraying where water once preferred to flow. Put all of this together, multispectral imagery, radar, LiDAR, and you can draw a surprisingly precise map of where ancient channels run, even if today the surface is nothing but fields, dunes or suburbs. But remote sensing is only half the story. It tells you something is different here. It doesn't tell you exactly what that something is, or when it happened. For that, you have to leave orbit and pick up a shovel. Or better, a drill. Geologists talk about ground truth for a reason. A line on a satellite image might be an old river. It might also be a buried road, a pipeline, a soil boundary, a fault, a dune crest, or a ploughed field. To turn those lines into real paleorivers, researchers go out and sample the actual sediment. The classic tool is the core, a narrow cylinder of earth pulled up from a few meters to tens of meters below the surface. Split that core open and you're looking at a vertical timeline of the site. Layers of fine laminated mud might mark a quiet lake or floodplain. Thick beds of clean sand and rounded gravel usually scream channel. Mixed, chaotic deposits could be flood events or debris flows. Grain size matters. Active river channels generally carry and deposit coarser material than calm overbank areas. A core that transitions from sand and pebbles at depth to finer silts and clays higher up might be showing you the moment an old channel was abandoned, and its bed began to accumulate quieter floodplain mud. Fossils add more clues. Freshwater shells, fish bones, and aquatic plant. Remains pinned to a particular depth in the core confirm that water once flowed or pooled there. Pollen grains can reveal the surrounding vegetation at the time. Wetland plants versus steppe grasses versus desert shrubs, letting you tie river activity to broader climate conditions. Geochemistry fills in the final details. Different rivers carry different mixes of dissolved minerals and eroded rock fragments, depending on what they're cutting through upstream. By analyzing the elemental or isotopic fingerprint of the sand and mud, ratios of things like strontium, neodymium, or certain heavy metals, researchers can sometimes trace a buried channel back to a specific source area. That's how you distinguish, for example, an ancient branch of the Euphrates from an ancient branch of the Tigris, or a Nile-fed channel from a purely local wadi. All of this tells you that a vanished river was there. To connect it to post-Ice Age events, you need dates. River sediments are surprisingly datable, but each method comes with caveats. Radiocarbon dating is the workhorse for the last 50,000 years. If you find bits of charcoal, wood, plant remains, or shells within, or just above an old channel fill, you can measure the decay of radioactive carbon-14 and get an age estimate. That tells you, roughly, when that layer was deposited, or when organic material last lived. It's immensely powerful, but it's only as good as your sample. Old wood can be reworked into younger sediments. A single bit of charcoal might tell you more about a campfire upstream than the exact age of channel abandonment. Optically stimulated luminescence, or OSL, is another key tool. Sand grains in riverbeds are constantly being exposed to sunlight, which resets a kind of internal clock. Once they're buried deeper than light can reach, that clock starts ticking as radiation slowly accumulates in the crystal lattice. In the lab, scientists can measure that stored energy and estimate when the grains were last exposed to daylight, effectively when they were deposited. OSL works particularly well for sandy river deposits and can reach further back in time than radiocarbon in many cases. Other methods, like uranium series dating of carbonate crusts, or even cosmogenic nuclide dating of boulders in ancient terraces, can bracket the ages of river incision and abandonment on longer timescales. None of them give a perfect single birthday for a river, but together they can outline windows. This channel was active between about 14,000 and 10,000 years ago. This terrace was cut earlier, this floodplain later. When you combine remote sensing, ground truth, and dating, you can do something that sounds almost mystical: map a river that doesn't exist anymore. You start with satellite and radar data to trace likely paleochannels across a region, sinuous lines across a desert, drowned valleys on a continental shelf, abandoned distributaries on a delta plain. LiDAR helps refine the subtle topography. Field teams then target key points, bends, confluences, terminations. They core, log the sediments, collect fossils, take samples for radiocarbon and OSL. Back in the lab, dates come in. Some branches turn out to be too young. Others are far older than you need. Slowly a pattern emerges, a particular configuration of channels that were all active within the same time window. That configuration is your paleoriver system at, say, 12,000 years ago. Even if no water flows there today, even if cities and fields cover the floodplain, even if the whole thing lies under 60 meters of seawater, from there you can make the kind of maps that matter for our Babylonian question, not artistic impressions, but reconstructions grounded in physics, sediment, and isotopes. But these reconstructions are not perfect snapshots. They come with limits. It's important to keep in view when someone tries to draw a straight line from a modern paleomap to an ancient clay tablet. Dating always has uncertainty. A radiocarbon age comes as a range, not a single year, and needs calibration. OSL ages can carry error bars of hundreds or thousands of years. That's good enough to say late glacial versus mid-Holocene, but it's not precise enough to claim a river died out in, say, 10,800 BCE, and therefore must be the one on a tablet drawn in 600 BCE. Channels themselves are often discontinuous in the record. Erosion removes parts of them. Later rivers cut through earlier ones. Human activity modifies the landscape. Remote sensing might pick up only the best preserved segments. When you draw a continuous blue line on a paleomap, you're interpolating between data points, making educated guesses about the exact path. And then there's interpretive bias. Once you think you know what you're looking for, the lost channel of X, the Saraswati, an Ice Age branch of the Euphrates, it becomes dangerously easy to see that pattern everywhere. A faint line in satellite data that fits your hypothesis is embraced. Equally plausible lines that don't fit are ignored. Early rough reconstructions take on a life of their own in popular books and YouTube videos, even after specialists have revised or abandoned them. None of this means paleoriver science is unreliable. On the contrary, when multiple lines of evidence converge, imagery, cause, fossils, dates, the big picture is robust. Major river reorganizations at the end of the Ice Age are real, not speculation. It does mean, though, that connecting those reconstructed rivers to specific features on ancient maps requires a lot of caution. You're matching a noisy, incomplete geological record to a stylized, symbolic human artifact, and both sides of that comparison come with their own uncertainties. In the next sections, we'll look at concrete examples: the green corridors that once crossed the Sahara, the rivers of sand in Arabia, the shifting braids of Mesopotamia, and the debated case of India's Saraswati. In each case, we'll see how these tools reveal spectacular vanished rivers, and how tempting and tricky it is to tie them to stories and maps from thousands of years later. When you lay those Paleorhiva maps next to modern ones, something jumps out immediately. The big rivers don't stay put. We like to imagine them as permanent fixtures, blue lines carved into the planet. In reality, some of the most important rivers in human history have been shockingly disloyal to their own courses, especially out on their low, flat floodplains. Geologists have a word for one of the main ways this happens: avulsion. Avulsion is what you get when a river suddenly abandons its old channel and jumps into a new one, often during a single major flood. Not a slow, gentle migration over centuries, but a fast, decisive rerouting. To see why this happens, picture a huge lowland river like the Nile or the Ganges coming out of the hills. Once it hits the flat plains, something strange begins. Every time it floods, it spills mud and sand over its banks. That fine material settles right next to the channel, building up natural levees, slight ridges on either side of the river. Flood after flood, the levees get higher. The channel itself may also slowly fill with sediment. Meanwhile, the surrounding floodplain, a little farther away, doesn't get as much new material. Compared to the levee, it actually ends up relatively lower. Over time, the river is trapped in its own raised corridor, a kind of elevated waterway perched above its surroundings. It looks secure, but it's inherently unstable, because now gravity has a better idea. All it takes is one extreme event: a huge flood, an ice jam, a landslide upstream, a blockage of debris, anything that makes water overtop those levees in a weak spot. Once water starts flowing off the side, down that slightly lower ground, it cuts. Fast, that new path is steeper and more efficient than the old perched channel, so more and more of the flow gets captured. In a matter of days, weeks, or a few years, the main river can switch wholesale into the new course. The old channel is left high and dry, or maybe fed only during the biggest floods. On a satellite image centuries later, you see it as an abandoned crescent-shaped scar or a faint winding depression through the fields. On long, flat deltas, the Mississippi, the Nile, the Indus, the Ganges, Brahmaputra, this isn't a rare accident. It's the normal way deltas grow. Each avulsion sends the river to a different part of the coastline, building a new lobe of sediment and starving the previous one. Take the Mississippi. Over the last few thousand years, it has shifted its main outlet again and again, from Texas to the middle of the Gulf of Mexico to near modern New Orleans. The river you see on today's map is just one phase in that restless sequence. Now imagine being a Bronze Age scribe in a lowland like Mesopotamia. Your grandparents remember a branch of the Euphrates that fed a certain canal, watered a certain set of fields, perhaps ended in a marsh near a particular shrine. 50 years later, that branch is a muddy depression, and the main flow has slipped away to the east or the west, or split into multiple new arms. If you were mapping those rivers, which version would you draw? The one in front of you? The one your father insisted was the real river? The one older stories say used to reach a different coast? This is where avulsion collides with our question. A map that shows a wrong river mouth might not be describing some supernatural Ice Age relic. It might be capturing a perfectly ordinary but dramatic river jump that happened within living memory. Avulsion is only one lever in the system. Beneath those rivers, the ground itself is moving. Tectonics, the slow deformation of the Earth's crust, changes drainage patterns over thousands to millions of years, but sometimes in ways that are abrupt enough to matter to people as well. If part of a basin is gently subsiding, sinking under its own weight, under the load of sediment, or as plates flex, rivers are drawn toward it. Think of it as a slowly deepening bowl. Water will preferentially fill the lowest part. Over geological time, whole river networks can swing toward a sinking zone. The flip side is uplift. If a region is being pushed up by plate collisions, volcanic activity, or deep mantle processes, it can tilt an entire landscape. A barely noticeable change in gradient is enough to divert rivers. A stream that once flowed west may find its easiest route to the sea is now east. Watersheds can be captured, one river literally stealing the headwaters of another as divides migrate. In places like the Zagros Mountains east of Mesopotamia, or along the margins of the Indian Plate, these processes have been quietly rearranging river courses for a very long time. Over tens of thousands of years, tectonic warping can shift where major rivers enter a basin by tens of kilometers. Combine that with avulsion on the deltas, and the big picture starts to look less like a static plumbing diagram and more like a constantly redrafted sketch. Then, layered on top of all that, there's the ocean itself. At the peak of the last ice age around 20,000 years ago, so much water was locked up in ice sheets that global sea level was roughly 120 meters lower than it is today. Coastlines were not where you see them on a modern globe. Continental shelves, the broad, shallow regions off many coasts, were exposed as dry land. Rivers carved deep valleys across those now drowned plains, racing toward a shoreline that might have been hundreds of kilometers farther out. As the climate warmed and the ice sheets melted, sea level didn't rise smoothly like water in a bathtub. It rose in pulses, with episodes of relatively rapid increase. Each pulse pushed the shoreline landward, flooding those valleys. River mouths, deltas, estuaries, they all marched inland. In many places, especially where the shelf is broad and gentle, the original Ice Age river mouths now lie far offshore, under tens of meters of water and younger marine sediments. What looks today like a simple coastal plain, ending in a narrow strip of beach, used to continue into a wide lowland dotted with channels, lakes, wetlands, and perhaps human camps. For ancient people living through this transition, the changes would have been profound and disorienting. No, they didn't watch the sea advance like a Hollywood tsunami, swallowing miles of land in an afternoon. On a human timescale, average rates of sea level rise were more like centimeters per year, with spikes that might reach a few tens of centimeters in particularly fast phases. That sounds slow, but it adds up. Over a few generations, a coastal community could see a favorite fishing lagoon become a bay become open sea. A known river mouth might shift inland, floodplains become tidal marshes, once fresh channels turn brackish and then fully marine. And remember the deltas. As sea level climbs, rivers have to dump their sediment into deeper water. They may respond by building new, more inland lobes, or by avulsing into slightly different paths that can keep up with the changing base level. Old distributary channels can be drowned and infilled with estuarine mud. New ones slice across former dry land. Fast forward 10,000 years. You're a geologist with sonar and drilling rigs, and you can map those drowned valleys and buried deltas across the continental shelf. But to an Iron Age mapmaker with no knowledge of ice sheets or eustatic curves, the only thing visible is that certain stories insist the river once met the sea in a place where, today, it clearly doesn't. From their perspective, that can look like a mystery. From ours, with sea level curves and tectonic models, it starts to look like normal Earth history. The crucial point for our impossible map puzzle is this. None of these processes is purely geological in the sense of being too slow to matter to humans. Avulsions can happen within a lifetime. Historical records from China and the Yellow River Basin describe catastrophic course changes that rewrote maps in a matter of years, drowning some cities and leaving others suddenly stranded far from the main channel. The lower Mississippi has been trying hard to jump into the Atchafalaya. If engineers let it, huge stretches of what we now call the Mississippi would be reduced to a sidearm in decades. Tectonic warping is slower, but not always glacial. Even a millimetre or two of uplift or subsidence per year, sustained over centuries, can change flood patterns, alter marshes, and move shorelines across archaeological time. In places like the Po Plain in Italy or the Nile Delta, parts of the land are subsiding under sediment load and groundwater withdrawal today fast enough that towns notice increased flooding within a human career. Sea level rise is the most global and most dramatic in the long run. The jump from Ice Age low stand to roughly modern levels took on the order of 10,000 years, but local impacts were staggered and at times abrupt. Certain coastal lowlands would have transitioned from inland plains to estuaries to shallow seas over just a few centuries, a handful of cultural horizons in archaeological terms. When an ancient text or a Babylonian clay tablet or a later Greek account talks about rivers that once flowed here but now flow there, it doesn't automatically mean someone had secret Ice Age satellite images. It can just as easily mean they were watching and mythologizing the very real, very dramatic behavior of large rivers on a restless planet. In the next sections, when we talk about the Sahara's green corridors, the rivers of sand in Arabia, or the vanished branches of the Tigris and Euphrates, keep this in mind. Rivers move, coasts migrate, mouths drown. What looks like an impossible mismatch between an ancient map and a modern globe might simply be a snapshot of a world in mid-transformation. To really feel how strange ancient hydrology can get, leave the deltas and coastlines for a moment and walk straight into what looks today like the most hopeless place on Earth, the Sahara. On a modern map, it's this gigantic yellow smear across North Africa. Sand seas, bare rock, almost no permanent rivers, very few lakes. It's the textbook example of a desert, but that's only the Sahara we happen to be living with right now. Between about 14,500 and 5,500 years ago, timing varies by region. Climate patterns over North Africa were radically different. The whole belt of tropical rainstorms, the monsoon system, was shifted north. Earth's orbit and tilt went through one of those cycles that changes how sunlight is distributed between seasons, and the African monsoon followed. Geologists call this interval the African humid period. Archaeologists and paleoclimatologists often just call it what it felt like on the ground, the Green Sahara. If you could drop into that world, huge parts of what is now sterile desert would look more like savanna. There were seasonal and even perennial rivers crossing regions that get almost no rain today. Shallow lakes filled basins that are bone-dry salt flats on satellite images. Swamps, reed beds, gallery forests along channels. Hippos, crocodiles, elephants, fish, human camps and villages strung along shorelines and riverbanks. We don't have to imagine all this from scratch. The evidence is everywhere once you know how to read it. Lake beds hundreds of kilometers wide, like the ancient Mega-Chad Basin in the south-central Sahara, are ringed by fossil shorelines, old beach ridges you can trace for tens or hundreds of kilometers. Drill cores pull up lake muds full of freshwater diatoms, pollen from grasses and trees, not the sparse desert shrubs that live there now. Across the central Sahara, radar and satellite data reveal ghost rivers, broad, branching depressions buried under sand but still etched into the bedrock topography. They have tributaries, meander scars, cut-offs, everything you'd expect from big, active drainage systems. Today they're invisible on the ground, unless a rare storm sends a flash flood roaring through one of the old corridors. These are the Sahara's paleo-drainage systems, ancient river networks reconstructed from a combination of satellite imagery, ground surveys and subsurface data. One of the best-known runs beneath the eastern Sahara, trending roughly north-northeast toward what is now the Nile. It's often called the Tushka or Sahara Paleoriver system. In some reconstructions during peak humid phases, it may have carried water from highlands in what is now Sudan or Chad all the way toward Egypt, either joining the Nile or feeding wetlands and lakes on its western side. Farther west, there are the buried channels that once fed those mega-lakes in the Chad Basin, and still farther, pathways that likely connected southern watersheds to the Mediterranean coast through what are now hyper-arid belts in Algeria and Libya. Think about what that means for people. For thousands of years during the Green Sahara, you could walk from sub-Saharan Africa to the Mediterranean, not by crossing an endless dune sea, but by following chains of lakes, wadis and shallow rivers. These were green corridors, migration routes for animals and humans, arteries of trade and communication. Rock art from this period shows cattle, hunters, swimming people, boats, not lone, desperate caravans inching between dunes, but thriving communities living off a landscape that, to our eyes, should be impossible. Then, inexorably, the climate system swung again. The orbital configuration changed, the monsoon belt shifted southward, and rainfall over the Sahara began to decline. Not in a single year, not as a cinematic sandstorm, but over centuries and millennia. Lakes shrank, then vanished. Rivers became seasonal, then intermittent, then nothing but dry beds and weak groundwater traces. Grasslands gave way to scrub, then sand and bare rock. Humans didn't just vanish with the lakes, they moved. Some followed the retreating rains south. Others gravitated toward refuges that still offered reliable water. The Nile Valley, the Mediterranean coast, the Atlas foothills, oases tied to deep aquifers. In those refuges, memories of the old routes would have come along for the ride. This is where the Green Sahara connects back to the problem of impossible rivers on ancient maps. Imagine you're living in, say, the early dynastic Nile Valley, or along the North African coast in the Bronze Age. To you, the Sahara is already a formidable barrier. But your grandparents' stories and the stories of the desert pastoralists who still trade with you talk about other ways across. They mention places where the river once flowed, names of dried-up lakes, valleys where, if rain falls, water still runs along a particular path. Caravan routes thread those old basins and riverbeds, because even a dead river is a good road. Gentle slopes, predictable passages between rock outcrops, scattered wells where water still lingers underground. Over generations, those pragmatic bits of knowledge that you can cross by this wadi, that there is a salt pan where a lake once stood, that a certain route is cooler or safer, turn into oral maps. They get wrapped in myth, tales of lost waters, of a time when there were rivers in the desert. Now layer in the fact that traders, nomads and travellers are the ones who keep using those corridors the longest. They're the ones who eventually talk to scribes in cities like Carthage, Alexandria, or later Greek and Roman centres. They supply the raw geographic gossip that ends up, much later, in written itineraries, periploi, and, eventually, drawn maps. A mapmaker 1,000 years after the Green Sahara doesn't need to have seen a single flowing Saharan river to draw one. All they need is a consistent story that beyond this oasis, the route follows the bed of a dry river for many days and then reaches another depression, where there used to be a great lake. How do you symbolize that? With lines and blobs of blue ink that, on a clay tablet or parchment, look suspiciously like actual rivers and lakes. Add another layer, place names. Toponyms often outlive the things they describe. Around the world you find towns named Lakeview with no lake, Newport with no port, Ford with no crossing. The land changed, the words stuck. North Africa is full of names that hint at past water. terms for springs, lakes, wadis, marshes, sometimes in languages that are themselves dead or heavily layered. A later cartographer, working from lists of regions and place names, could easily string those watery labels into a mental picture of a much wetter interior than actually existed in their own day. So when we look at a later ancient or medieval map that shows bold blue lines cutting across what we know to be hyper-arid desert, we have options besides they somehow saw the Sahara of 10,000 years ago. It might be a stylized representation of caravan routes that happen to follow old river valleys, an echo of the Green Sahara preserved in regional lore and fossilized in place names. A conceptual guess: if there are oases here and here, something must connect them, drawn as a river, even if, on the ground, that something is a chain of wells and dry wadis. The problem is that the timescales don't line up neatly. The African humid period was winding down by around 5,500 years ago in many parts of the Sahara. The most water-rich, river-laced phases were thousands of years earlier still. By the time we start getting the majority of our surviving ancient maps, first millennium BCE and later, the Sahara was already broadly desert. Can fragmentary oral memory really bridge gaps of 3, 4, 5,000 years? Possibly in motifs and myths, probably not in the precise geometry of river networks. Trade routes can preserve corridors, but they can't resurrect every tributary and marsh. On top of that, the paleo-drainage picture itself is complicated, and still being refined. Some buried channels may have flowed strongly only during certain peaks of humidity. Others might have been more like chains of wetlands than classic through-flowing rivers. Tying any specific symbolic line on a Babylonian or Greek map to a specific paleoriver traced by satellite is at best an exercise in educated speculation. So when you hear claims that an ancient map perfectly matches the Green Sahara, there are two things to keep in mind. First, the Sahara really did have rivers and lakes on a continental scale not that long ago in geological terms, and humans were absolutely there to see and exploit them. Second, the path from those lived landscapes to the symbols on any surviving map is twisted, filtered through climate shifts, migrations, oral traditions, trade, place names, guesswork, and artistic convention. That doesn't make the match meaningless. It just means we have to be careful about how literally we read it. In the next section, we'll see how a similar story plays out on the Arabian Peninsula, a place early texts sometimes describe as laced with rivers, but that we know today as almost nothing but sand. If the Green Sahara feels like a plot twist, Arabia is the sequel that most people don't even know exists. Today, the Arabian Peninsula is almost a caricature of dryness. Endless dunes in the Rub al-Khali, bare gravel plains, rugged mountains feeding almost nothing. A few short violent flash floods, then back to dust. But peel back the last few thousand years with the same tools scientists used in the Sahara satellite imagery, ground surveys, sediment cores, and a different Arabia starts to come into focus. Across the peninsula, there's a hidden spiderweb of dry valleys, wadis. On the ground, a wadi might just look like a dusty channel, a stony depression that only carries water after rare storms. From orbit, though, you can see they're not random at all. They branch, merge, meander, cut across the landscape in patterns that are unmistakably fluvial, river-like. In northern Arabia, radar and optical satellites trace big wadis trending toward the now dry interior basins and, in some cases, toward the Persian Gulf. In the southwest and south, dense networks of valleys drain the highlands of Yemen and Oman out toward what is now desert or coast. Some of these systems are modest, seasonal streams that never would have rivaled the Nile or the Tigris. Others, though, look like the skeletons of real rivers, active for thousands of years under wetter climates. How do we know they actually carried water for long periods, and not just the occasional catastrophic flood? You dig? In several major wadis, khors and trench walls expose layers of river gravels, sands and silts stacked, like a layer cake. You find freshwater shells, aquatic snails, pollen from grasses and trees that can't survive on today's rainfall. Optically stimulated luminescence dating, measuring when grains of sand last saw sunlight, shows repeated phases of flow between roughly 130,000 years ago and as recently as the early Holocene, around the time the Sahara was green. Lake deposits tell the same story. In what are now barren depressions, geologists find thick packages of lake muds, sometimes with shorelines you can walk along. Some of these lakes were big enough to support fish, water birds, and, critically, people. The driver behind these wet pulses wasn't magic, it was monsoon physics. Just like North Africa, Arabia sits on the margin of powerful seasonal wind and rain systems. Changes in Earth's orbit and tilt don't care about our political maps. They adjust where and when the sun's energy hits, and the monsoon belts respond. When the Indian Ocean monsoon shifts north and intensifies, moisture-laden air can push deep into Arabia. Mountain ranges in Yemen and Oman wring that moisture out as rain. Wadis that are bone-dry today can become seasonal or even perennial streams. Interior basins can fill, forming lakes and wetlands. When the monsoon retreats south again, the whole system dries, leaving behind fossil riverbeds and stranded shorelines. Over the last few 100,000 years, this seesaw has played out again and again. For humans, each wet phase turned parts of Arabia from a deadly barrier into a bridge. Look at a map of modelled paleorivers in Arabia, and then compare it to genetic and archaeological evidence for human migration. Corridors line up. Routes from northeast Africa into Arabia and onward into the Levant and Iran tend to follow belts where wadis and paleolakes cluster. Stone tools found along some of these corridors, especially Middle Stone Age-like assemblages in southern Arabia, hint that our species, or closely related populations, used these green windows to move out of Africa in pulses long before the famous 60,000-year dispersal that shows up in most popular timelines. Later, in the early Holocene, when Arabia had its own humid phase, you start to see more substantial settlements. Hearths, animal bones, worked stone clustered around now dry lake basins. In some places there are hints of early herding. These weren't just tiny bands dashing across a hostile landscape. They were communities living for generations in what, to them, was habitable countryside, threaded by rivers that no longer exist. So if Arabia once had these rivers of sand that actually flowed, does any of that show up in our surviving maps or texts? This is where things get tricky. By the time we start getting detailed geographic descriptions of Arabia from late Bronze Age inscriptions, Assyrian and Babylonian records, then Greek and Roman writers, the peninsula is already largely arid. But the language they use is suggestive. Ancient South Arabian inscriptions refer to wadis and seasonal streams with specific names. Later Arabic geography is full of terms for valleys that clearly once carried more water than they do now. Some classical authors speak of Arabia Felix, fortunate Arabia, with irrigated fields, frankincense groves, and, crucially, references to rivers in the south. On a few Greco-Roman maps and world sketches, you see lines that look like rivers penetrating the Arabian interior, especially in the southwest. Medieval Islamic geographers often show networks of wadis and watercourses across Yemen and Hijaz that are much more elaborate than modern perennial rivers alone would justify. Could some of those lines be dim echoes of earlier wetter phases? Maybe. What's almost certain is that they record at minimum seasonal flows and flood channels, wadis that mattered for travel, farming, or flash flood risk. Just like in the Sahara, caravan routes often hug wadi systems because they offer easier gradients, occasional wells, and, in good years, grazing. A mapmaker trying to turn oral itineraries into ink on parchment might reasonably promote those wadis into rivers. There are even more speculative connections. Some researchers have proposed that certain major Arabian wadis, visible from space, like systems draining toward the now submerged Gulf Basin, could be faintly reflected in Mesopotamian or later maps that show enigmatic rivers coming out of Arabia or the Sea of the Lower World. If sea level was lower and the Gulf partly dry during glacial periods, that basin itself may have hosted rivers and wetlands that drew people and myths alike. The problem is correlation versus causation. Yes, there are paleorivers in Arabia. Yes, there are ancient and medieval maps and texts that mention or depict rivers in roughly the right general regions. But our surviving cartography is late, stylized, and often more concerned with routes and political regions than with hydrology in a modern sense. We can say that Arabia was not always as dry as it looks today. We can say that long-lived river corridors and lakes once offered migration routes and settlement zones that were absolutely real to the people who used them. We can say that names, stories, and trade itineraries preserved some memory of those wet phases into historical times. What we can't do, at least not honestly, is point to a single Babylonian tablet or medieval map and declare this is a literal record of a river that vanished 100,000 years ago. At best, what we're seeing are shadows, suggestive overlaps between ancient drawings, place names and landscapes that climate and time have erased. In the next section, we'll move to a region where our textual and cartographic record is much richer, Mesopotamia, and watch rivers we actually can track through both sediment and scribal ink twist, jump and disappear under their own shifting loads of mud. Mesopotamia looks solid on a modern map. Two big blue lines, Tigris and Euphrates, running more or less parallel, drifting together into a single channel before they meet the Gulf. But that clean picture is a lie of convenience, drawn on top of a landscape that is anything but stable. The lower Tigris-Euphrates plain is essentially one gigantic, very slow-motion delta. For thousands of years, those rivers have been dumping silt and sand into a flat, almost featureless basin. When a river enters that kind of terrain, it behaves like a bored child with a hose in a sandbox. It wanders. The main channels of the Tigris and Euphrates have shifted laterally, split, rejoined, died, and been reborn countless times over the last 10 or 15,000 years. They build up their own beds with sediment until they're riding high above the surrounding land on natural levees. Then one big flood is enough to punch a breach. The water spills sideways, and suddenly a minor branch is the new main river. Geologists call that kind of jump an avulsion. In Mesopotamia, it's the rule, not the exception. Add in tectonic subsidence, a basin that's literally sagging under its own sediments, and long-term sea level rise drowning the lower reaches, and you get a plain where shorelines, marshes and river mouths have marched back and forth by dozens of kilometres since the end of the last ice age. Now drop people into that system. By the time we get real cities, Uruk, Lagash, Nippur, the landscape is no longer just fluvial, it's engineered. The same silt that makes the rivers unstable also makes the floodplain absurdly fertile. So the Sumerians and their successors do the obvious thing. They start cutting canals. Not one or two, but hundreds. Irrigation canals, drainage channels, navigation cuts, diversion ditches running off both the Tigris and Euphrates and off their own distributaries. Some are narrow local features. Others are essentially artificial rivers, tens or even hundreds of kilometres long, moving water from one basin to another, keeping fields alive, feeding city harbours, or deliberately stealing flow from a rival's territory. Over time, the line between river and canal gets blurred. A human-cut canal can, if it's big enough and maintained long enough, start to behave like a natural channel. It incises, it builds levees, villages cluster along it. Scribes give it a name and list it in temple accounts right alongside the Tigris and Euphrates. In some cases, what began as a side canal ends up capturing so much flow that the original natural branch withers. On later maps, It looks like the river has always been there. This is why trying to reconstruct a pure natural river network in ancient Mesopotamia is so difficult. When archaeologists and geomorphologists go looking for old channels, they see a palimpsest. Satellite imagery shows ghost rivers, sinuous depressions, subtle colour differences in crops, slightly higher or lower strips of land that mark abandoned beds. Coring those features turns up river sands and silts, sometimes capped by the brick rubble of long-abandoned settlements. Radiocarbon dates on organic material let you sequence which channels were active when. But the sediments don't tell you who dug what or what the locals called it. That's where the tablets come in. Cuneiform administrative records are obsessed with water. Field allotments are defined by canals and ditches. Rations are paid to work crews digging or maintaining specific channels named one by one. Legal disputes hinge on whose land a breached levee flooded. Royal inscriptions brag about new canals, complete with flow directions and their connection to the great rivers. From these dry lists, you can start to overlay an invisible network onto the physical landscape. If a tablet from Lagash around 2400 BCE mentions a canal running from the Itorungul to a certain temple district, and 1,000 years later an Assyrian inscription complains about dredging silt from something with a suspiciously similar name, and in that same area satellite imagery shows an abandoned sinuous channel, you can cautiously link them. Do that across tens of thousands of tablets and patterns emerge. You see phases when certain branches of the Euphrates carried most of the flow, and phases when those branches dwindled while canals to the Tigris were expanded. You see cities that were once riverine ports stranded kilometers from any active channel because the river deserted them. You see the rise of places like Babylon tied directly to their position at key junctions of this artificial natural water grid. Now imagine trying to summarize that mess on a clay tablet the size of your hand. If a Babylonian scribe sits down to draw what we'd call a map, he's not doing geomorphology. He's translating administrative reality and cosmology into lines and labels. For him, a major irrigation canal that feeds 3 cities and requires thousands of labourers every year is functionally as important as a natural river. It may even be older than any living person can remember. So when he draws a watercourse, gives it a name, and lets it flow across the tablet, he's encoding a working landscape, not a pristine one. Fast forward a few hundred or a few thousand years. The canal silts up. The levees are breached and never repaired. The city it served declines or shifts closer to a different branch. New channels are dug somewhere else. Within a few generations, the old line of water is just a shallow depression leading nowhere. Then finally, nothing more than a faint variation in soil colour that only shows up from the air. The map, meanwhile, survives in some palace library or temple archive, or is copied because it's considered a classic model of the world. To a modern eye, looking at that tablet without the context of vanished canals and avulsed rivers, it can seem like the scribe has drawn a mystery river that doesn't match today's Tigris-Euphrates system at all. Draw enough of those maps from different periods, and you can convince yourself there's some lost Ice Age megachannel encoded in the tradition. But there's a risk here. On a low, muddy, rapidly aggrading plain like Mesopotamia's, a big canal dug in the 3rd millennium BCE and used for centuries will leave a physical trace that, to remote sensing or a shallow core, can look a lot like a natural distributary. If you're not careful with dates and with the written evidence, you can misread a Bronze Age engineering project as a relic of a glacial river system. Some proposed ancient river alignments in southern Mesopotamia have already gone through this cycle. First, they were hailed as clues to a completely different prehistoric drainage. Then, as more detailed dating and text correlations came in, it became clear that at least parts of those features were historical canals, reusing or slightly modifying older natural channels. That doesn't mean there were no earlier branches. It does mean you have to disentangle 1,000-year canal histories from 10,000-year river histories, one core and one tablet at a time. When you put the pieces together, a more grounded picture emerges. An old Mesopotamian map that seems to show impossible rivers may simply be catching the Tigris-Euphrates system mid-shift, or spotlighting a canal network that no longer exists on the surface. The water was real, the channels were real, but their lifespans were short compared to the age of the floodplain itself. Before we jump to Ice Age explanations, we have to exhaust that nearer, muddier possibility that we're looking at the ghost of an engineered waterway or a temporarily dominant branch, not a window onto a world 12,000 years gone. And this isn't just Mesopotamia's problem. Farther east along the Indus and in northwest India, the same combination of shifting rivers, engineered canals, and fading memories has produced one of the most controversial lost river debates of all, the story of the Saraswati. Open a Vedic hymn, and the Saraswati isn't just a river, it's a presence. She's called best of mothers, best of rivers, best of goddesses. She flows from the mountains to the ocean. She's associated with wisdom, speech, inspiration. In some of the oldest layers of the Rig Veda, her name appears more often than the Indus or the Ganges. So when modern scholars and nationalists and local communities all go looking for the Saraswati on a map, they're not just chasing a body of water. They're chasing a sacred geography, a river so central to the earliest Sanskrit texts that, if we could pin it down, it might anchor the whole timeline of early South Asian civilization. The search has mostly focused on one obvious suspect, a dry, meandering depression running through Haryana and Rajasthan, known today as the Ghaggar Hakra. On satellite images, it looks like a classic ghost river line. A broad, sinuous belt of pale soils and subtle elevation changes, winding across the plains toward what is now the Rann of Kachch. Ground surveys and cores show fluvial sands and silts under the surface. Archaeological sites, especially from the Bronze Age Indus or Harappan civilization cluster, along its course like beads on a string. If you're looking for a big, ancient river that later vanished, this has all the right vibes. The question is, how big and when? One school of thought argues that during the early Holocene, maybe between about 10,000 and 6,000 years ago, the Ghaggar Hakra was fed directly by one or more Himalayan glaciers. In that view, major rivers like the Sutlej or the Yamuna used to pour southwest into this channel, not into the Indus or Ganges as they do now. The Saraswati of the Vedas, the argument goes, was this Himalayan-fed, year-round, high-discharge river. Only later did tectonic tilting and river capture divert its headwaters elsewhere, leaving the lower course to dry up. It's a compelling story. It links mythic description, from the mountains to the ocean, with real geomorphology, ancient channels that point from the Himalaya into the Ghaggar corridor, abandoned fan lobes that look like former river mouths, and a string of settlements that make sense along a reliable water source. But as more data have come in, that neat picture has started to blur. High-resolution dating of sediments, using radiocarbon and optically stimulated luminescence, suggests that the last time truly big, perennial Himalayan flow occupied some of those paleo-channels was much earlier than the peak Harappan period. We're talking before 8,000 or even 10,000 years ago in some cases. By the time the Bronze Age cities along the Ghaggar Hakra were thriving, the evidence points to a smaller, more seasonal system, fed mainly by monsoon rains and foothill streams. In other words, the Harappans may have built their towns along a river that was already in decline. From this, a second interpretation emerges. In that view, Saraswati in the texts is not describing a single Indus-sized Himalayan river as it existed in the Harappan heyday. Instead, the tradition could be remembering a more modest but still significant monsoon-fed river system. What the Ghaggar Hakra seems to have been in the 3rd and 2nd millennia BCE, elevated and idealized by centuries of ritual use and poetic exaggeration. A third, more cautious camp goes further. They suggest that Saraswati might be a composite memory, a weaving together of multiple water realities across time. Early pastoralists and farmers moving between the Indus, Gaga, and later Ganges basins would have known many rivers, many channels. Over generations, as climates shifted and rivers avulsed, the specific hydrology changed, but the ritual language and sacred names persisted. Saraswati could be part Gagahakra, part Upper Yamuna, part metaphor for all nourishing, speech-giving waters. Here's where tectonics and climate come back into the story. The northwest Indian plains sit at the toe of the Himalaya, where the crust is being crumpled and lifted by ongoing collision. Even slight shifts in elevation, millimetres per year over thousands of years, can change which way a river's headwaters tilt. Combine that with the massive sediment loads carried off the mountains, and you get a landscape primed for capture events. One river pirating the flow of another, one valley suddenly abandoned while a neighbouring one is carved deeper and deeper. Overlay climatic change on top of that. Early Holocene South Asia saw a stronger monsoon than today. More summer rain, more runoff, more reliable seasonal floods. As the monsoon gradually weakened after about 6,000 years ago, many rivers shrank, especially those that depended mainly on rainfall rather than glacial melt. A channel that once flowed 10 months of the year might become a flashy seasonal stream, then a chain of ponds, then a dry bed that only carries water in exceptional years. When you trace all this out, you end up with a plausible pathway from major, named sacred river to paleochannel under desert scrub in just a few thousand years. So can maps, or in this case textual mental maps, really preserve the memory of a river that no longer exists in the form that inspired the stories? Possibly, but the Saraswati debate shows how tricky that is. On the one hand, the broad correlation is hard to ignore. Ancient hymns talk about an important river system in roughly the right part of the subcontinent, and modern remote sensing reveals a big, abandoned channel there. Archaeology finds dense occupation along that line in the right general time frame. It would be weird if there were no connection at all. On the other hand, the details don't line up cleanly enough to declare the case closed. Does Saraswati map best onto a specific Gagahakra reach? Onto a phase when the Sutlej or Yamuna fed that system? Onto a network of seasonal streams that together formed a culturally central river? Or is the text reshaping older hydrological realities in the service of later ritual geography? Different scholars answer those questions very differently. Some papers confidently label Gagahakra as the lost Saraswati, a full-fledged Himalayan river that dried due to tectonic shifts in the late Harappan era. Others push back, pointing out mismatches between sediment ages, flow volumes, and the likely dates of the earliest Vedic compositions. Still others avoid hard identifications altogether, arguing that our chronological resolution just isn't good enough yet to line up river histories with textual layers at that level of precision. And floating over all of this are political pressures. In modern India, the Saraswati has become entangled with questions of heritage and identity, proving that a mighty Saraswati once flowed through today's national territory, nourishing an indigenous urban civilization, is an attractive narrative for some groups. That can skew which hypotheses get promoted in popular discourse, and which uncertainties get quietly downplayed. From a scientific standpoint, the Saraswati story is a stress test of our standards of evidence. How tightly do we need dates to match before we say a ghost river and a sacred river are the same? How do we separate glacial headwater phases from monsoon-fed phases in a single channel? How much weight do we give to poetic descriptions of flow and direction? And how do we guard against our own desire for neat, satisfying identifications? Whatever answer you favour, one lesson is clear. The Saraswati tradition likely does encode real hydrological history, but in a compressed, mythologized form. It shows that human cultures can remember rivers that shift, shrink, or vanish. It also shows how quickly those memories can be reshaped, layered, and politicized. So when someone points to an ancient text or a schematic map and says, "Look, here's a river that no longer exists, proof of an impossibly old world map," we have to be careful. The Saraswati reminds us that the line between a precise cartographic record and a shimmering palimpsest of changing rivers and changing stories is very thin, and it raises a deeper question that goes beyond any single river. If cultures can carry these half-remembered, half-mythic watercourses forward for millennia, how exactly does that knowledge travel, especially before anyone is drawing lines on clay or paper at all? To get at that, we have to peel away our own assumption that geography means top-down, bird's-eye diagrams. For most of human history, maps weren't something you looked at. They were something you carried in your head and performed with your body. Anthropologists sometimes call these mental maps, but that phrase can sound too static, like a little paper chart folded up inside your skull. In practice, this kind of knowledge is dynamic and sequential. It's not, a river is here, a mountain is there. It's, from this spring you walk until the third hill with the twisted tree. Then you turn where the ground turns red. Then you follow the ridge until you can see the twin peaks, and the water you want lies in the notch between them. The Australian Aboriginal songlines are one of the clearest examples we know. In those traditions, the route is encoded in story and melody. Each verse corresponds to a particular stretch of country. As you walk, you sing the land into order. This rock, this soak, this stand of trees, this crossing. Someone who knows the songs can navigate hundreds of kilometers of desert without ever consulting a graphic map, because the geography is embedded in the narrative. The song is the map. You see echoes of this almost everywhere once you start looking. In the Mediterranean world, long before Ptolemy draws coastlines on parchment, you get sailing periploi itinerary texts that say, in effect, from this harbour, sail east for so many days until you sight such and such promontory. There is fresh water and a sheltered anchorage. Beyond that, a dangerous shoal. Medieval pilgrims to Jerusalem wrote guidebooks that were basically verbal tracklogs. After the bridge, the road climbs. On the right is a village with 2 churches. The next inn is a day's march. In Central Asia, steppe traders and caravanners built up oral checklists of wells, passes and wintering grounds tied to seasonal rhythms and winds. In the Pacific, wayfinders memorized star paths, swell patterns, bird behavior, and sequences of islands, a kind of 4-dimensional mental atlas where time of night, season, and direction all interlock. All of these are route-based geographies. They're not about abstract positions on a grid. They're about how to get from where you are to where somebody, at some point, needed to go. Once you realize that, something important clicks into place. If your map is a story, then passing on the map just means telling the story again. Parents recite it to their children around a fire. Guides chant it as they lead a caravan. Pilgrims retell it when they reach a shrine. Each telling reinforces a chain of landmarks, distances and water sources stretched out over real space. And crucially, these chains don't have to be traversed by a single person alive today. A trader takes his goods from city A to city B, another picks them up and carries them to city C. A third moves them on to city D. Yet by the time someone in D is describing the route to a curious scribe or priest, they might be able to outline a continuous path. A, B, C, D, even if no one individual has ever made the whole journey. Information accumulates across generations the way sediments do in a river valley. Pilgrims form another powerful transmission network. A shrine draws people from dozens or hundreds of communities, each bringing their own local knowledge. They swap stories on the road: which ford washed out last spring, which town has a new market, which valley is no longer safe. Then they carry those updates back home and incorporate them into their own mental itineraries. Over centuries, this builds what you might call a continental memory of routes and rivers. It's patchy, uneven, often wrong in the details, but remarkably robust in its broad strokes. You don't need satellites or surveying instruments to know that if you travel 3 months northwest, there's another great river where people grow a certain grain and worship a certain god. Names are one of the stickiest parts of this memory. Place names can cling to landscapes long after the original feature has shifted or vanished. A dry valley might still be called riverbed. A brackish lagoon might still carry a name that means sweet spring. A settlement moves a few kilometres to better ground but drags its old name along, so on some level the past geography remains attached to the present one. We see this everywhere. Towns named for fords on rivers that have migrated away, ports now stranded inland that still bear names meaning harbour or mouth. In the Near East, you get ancient hydronyms, river names that persist even as channels avulse across their own floodplains. The sound of the name becomes a kind of fossil. This matters for our mystery maps because a later cartographer doesn't have to personally see a vanished river to put something roughly in the right place. Imagine you're a scribe in a Bronze Age city, centuries into a tradition of trade and pilgrimage. You never left the valley, but you talked to merchants who did. One tells you, beyond the great western desert, after 10 days of dry country, there's a land called such and such where a river once flowed, but now it's mostly dry except in certain seasons. Another, from a different generation, remembers his grandfather's story about a long journey that crossed the old river plain where ruined canals still glint after rain. You don't have orthophotos or topographic surveys. What you have are reports, place names, travel times, directions of the sun, descriptions of what's upstream and downstream from a king's border. So you begin to compile. You draw a line for your own river, then another for the neighbours, then sketch in a third based on the tale that says from city X, go 7 days towards sunrise, and you will meet the lost river's bed. You might compress distances, rotate directions a bit, merge 2 different traditions into one stylized channel. But underneath the distortions, you're encoding something real, that there is or was a dry river land a certain way from you, known by a particular old name. Fast forward another few centuries, climate shifts, channels move again, politics reorder borders. Your clay tablet or a copy of it survives. When we look at it now, we see a river in a place that, on the surface, seems wrong. It cuts across modern drainage divides or flows through what's now naked desert. We're tempted to say this can't be right. Either it's fantasy or it's evidence of some super ancient, impossibly accurate survey. But given what we know about how humans share spatial information, there's a middle ground. Oral itineraries can span vast distances through chains of traders and pilgrims. Mental maps can be stitched together from partial reports. Place names can outlive the water and keep pointing, vaguely but persistently, at where rivers used to be. A later cartographer can inherit all of that in second-hand form and do their best to freeze it into a picture. Is that picture going to be as precise as a modern hydrological map? No. Will it sometimes preserve, in stylized form, memories of waterways that had already changed or faded by the time the stylus touched clay? Very possibly. And once you accept that this kind of deep, messy, root-based knowledge is normal for human societies, you don't need to reach for ancient satellites or lost global civilizations every time you see an impossible river inked on an old map. You just have to remember that long before anyone drew coastlines, people were already mapping the world in stories. And stories can travel a very long way. So why, with all of that in mind, do people keep looking at ancient maps and insisting they show rivers that can't exist, or that prove some lost global science? Part of it is just how our brains are wired. Humans are pattern-making machines. Give us clouds, we see animals. Give us random noise, we hear whispers. Give us a cracked wall, we find faces. Psychologists have a word for this, pareidolia. It's the tendency to see meaningful shapes where there might only be coincidence. Now shrink that cracked wall down to a palm-sized clay tablet that's been through 3,000 years of earthquakes, floods, and fire. The edges are broken off. The surface is worn. Some lines were always symbolic, not literal. Others have flaked away entirely. You're looking at a fragment. But your brain hates fragments. It wants wholes. So the moment you see a faint curved line, your mind snaps to river. You notice another faint line nearby, and suddenly it's not just two scratches, it's a branching network. A third line points vaguely north. Now you've got a whole drainage basin and a story to go with it. That's pareidolia at work, but it rarely shows up alone. It loves to team up with something even sneakier, confirmation bias. Confirmation bias is what happens when you come to a piece of evidence with a story already in your head, and then you unconsciously cherry-pick whatever details seem to support that story. If you're already convinced there was a gigantic river running through the Sahara exactly 12,000 years ago, and you want that river to be proof of a lost civilization, then any ancient diagram that has a line vaguely where you expect it becomes irresistible. You zoom in on the parts that match your expectations, and quietly ignore the parts that don't. Maybe the cuneiform labels clearly say canal or border or mountain region, but you don't read Akkadian, and the blog you saw didn't mention that. Maybe the orientation text literally says sunrise is here, meaning the whole thing is rotated 90 degrees from what you assume. But your modern map app always puts north at the top, so your brain does the same to the tablet. That's another huge source of error: projection. We take our own mapping conventions, north up, scale bars, coastlines in recognizable shapes, and we project them backward onto cultures that weren't playing by those rules at all. Ancient Mesopotamian maps, for example, often put the east, the sunrise, at the top. Some Egyptian diagrams orient themselves to the Nile's flow. Medieval European maps glorify Jerusalem in the center and spin everything around it. If you grab one of these and mentally rotate it to make north right, you can completely scramble where the rivers seem to go. A line that originally meant go upstream toward the mountains might, under your rotation, now look like a river running straight out into the open ocean. A stylized circle meant to represent the bitter sea around the world can suddenly be reinterpreted as a giant freshwater loop enclosing a hidden continent. Add damage to the mix, and it gets worse. Most of the tablets and parchments that survive are not pristine technical drawings. They're chipped, burned, abraded. Some were recopied multiple times by scribes with varying levels of skill. Whole sections are missing, so modern editors try to reconstruct them with dotted lines and educated guesses. But those guesses rarely make it into the viral tweet or YouTube thumbnail. What you see online is a clean, high-contrast tracing. Bold river here, clear coastline there. The dotted lines are turned solid. The uncertainty brackets vanish. The question marks in the academic article get smoothed out into confident strokes in a meme. By the time the image hits a conspiracy forum, it's no longer partial reconstruction based on fragmentary evidence and comparison with later texts. Its ancient tablet clearly shows massive river system under Sahara, scientists baffled, and you'll notice the patterns in those online claims are almost always the same. There's usually a zoomed-in screenshot of some old object, cropped so you can't see the catalogue number or museum context. The caption says something like, "Mainstream archaeology can't explain this," without linking to any actual archaeological paper. There's a modern satellite image with a semi-transparent overlay of hand-drawn lines, and, surprise, the lines fit the features if you squint and ignore the parts that don't. If text is mentioned at all, it's a single translated word, river or sea, presented as if it settles the matter, even though the original phrase might mean region of rivers or beyond the sea, or be part of a mythic cosmology rather than a literal survey. You're not powerless in the face of this, though. There's a simple checklist you can run in your head every time someone claims an ancient map shows an impossible river. First, provenance. Where did this artifact actually come from? Which site? Which layer? Which excavation? Is it in a museum collection with a catalogue number you can look up? Or is it just found in a private collection with no paper trail? Real objects have boring details attached to them. Second, translation. Who translated the text, if there is any? Was it done by trained Assyriologists, Egyptologists, Sinologists, whatever the relevant specialty is? Can you find their names and read what they actually wrote, not just a screenshot of a single quote? Reputable translations often come with notes, caveats, alternate readings. If you're not seeing those, you're probably not looking at the original work. Third, scholarly consensus. Has this object been discussed in academic journals or monographs? Not just one outlier paper, but multiple studies over time. Do specialists broadly agree on what it depicts? A world diagram, a boundary charter, a canal system, or is its interpretation still hotly debated? Claims that no one can explain this almost always crumble once you realise no one just means people in my Facebook group. Fourth, independent geological match. If someone says the map shows a real vanished river, ask, does that claimed river also show up in modern geology or geomorphology? Do satellite images, sediment cores, or seismic surveys independently indicate a former channel in that location with similar orientation and extent? Or is the match only visible once someone has drawn thick, colourful lines over both images and told you what to see? When you stack these questions, a lot of dramatic claims fall apart fast. That doesn't mean there's nothing intriguing left. There absolutely are ancient maps that seem in broad strokes to echo paleocanals we now see from space. There are tablets whose impossible rivers start to look much less impossible once you correct for orientation, damage, and symbolic style. But to get at those real mysteries, you have to fight your own brain's love of patterns and certainty. You have to resist the rush of recognition when you think you see a perfect match, and patiently ask, is this line actually there, or am I drawing it in with my expectations? Is this river an empirical feature, or the ghost of my own confirmation bias? Because only after you clear away the illusions can you appreciate what's truly weird and wonderful about the ancient geography that does survive. And that's where we're going next, into the explanations that don't need "nobody can explain this" as a selling point. So let's do the thing the clickbait titles never do. Instead of jumping straight from "this looks weird" to "no one can explain it," lay out an actual spectrum of explanations. From the boring and well-supported, through the interesting but uncertain, all the way out to the edge of what the evidence might barely allow. And then ask, where does this particular impossible river really sit? At the most grounded end of that spectrum is Scenario 1. The map isn't as old as the wildest claims say it is, and the rivers on it aren't as impossible as they've been advertised. This happens constantly. An inscription is misread. A find spot date is treated like the creation date. A later copy of an earlier map gets called original. Suddenly a tablet from, say, 600 BCE quietly becomes 12,000 years old in a headline, because someone is rounding up the age of a geological event, or confusing radiocarbon years with calendar years, or just multiplying ancient by dramatic. Meanwhile, the rivers themselves might not be vanished superhighways from the Ice Age. They might just be channels that shifted in the centuries before the map was made. Rivers are restless. We've already seen how avulsion, tectonics, and sea level can send them wandering across their own floodplains. In Mesopotamia, branches of the Tigris and Euphrates have jumped around so much that ports that were once on the coast are now stranded far inland. In the Indus Basin, whole courses have migrated tens of kilometres in a human lifetime. Imagine a scribe drawing a map of the proper course of a river as it existed in the glory days of some earlier king, even though by his own time the main flow had already meandered away. For him, the older course is still the canonical one. It's where the tax records, boundary stones and legal traditions say the river should be. Fast forward a few thousand years, archaeologists dig up the tablet. Modern satellite images show the current river somewhere else entirely. A YouTube thumbnail screams, "Ancient map shows river that no longer exists, scientists stumped." But geomorphologists quietly point out that there's a fossil channel, a buried levee, a strip of old alluvium exactly where the mysterious line runs. Not a lost river from 12,000 years ago. A branch that was active a few hundred or a few thousand years before the scribe picked up his stylus. That's scenario 1. The dates got inflated, the normal behaviour of rivers got ignored, and a relatively mundane mismatch between map time and satellite time got turned into a mystery. It's not glamorous, which is exactly why it's usually right. Move a notch along the spectrum, and you get scenario 2. The rivers were never rivers in the first place. They were symbols, cosmology, sacred geography. A lot of the oldest maps aren't about getting you from village A to village B. They're about explaining how the world hangs together, how the gods arranged creation where the realms of the living and the dead touch, how the cosmic ocean encircles the land. In that kind of diagram, a line of water doesn't have to be a literal, surveyable channel. It can be a boundary between order and chaos, a mythic stream the sun god sails through every night, a schematic stand-in for the lands beyond. The Babylonian World Map we talked about earlier is a classic case. There's a central disk of land, a ring of bitter water, and then regions that almost certainly blend real distant territories with legendary zones. The rivers on something like that are doing double duty. They echo real features, but they're also narrative devices. If you come to a diagram like that expecting a modern topographic map, you will misread it. You'll see the ring ocean and think giant hidden river system. You'll see radial lines and think tributaries. You'll see a schematic division between this side of the mountains and that side and interpret it as a channel cutting across a continent. Scenario 2 says, the lines are there, but we're asking them the wrong question. We're trying to use a cosmological chart as if it were Google Maps. Once you correct for that, once you actually read the labels, look at the accompanying myth texts and compare with other ritual diagrams. A lot of impossible rivers quietly dissolve into metaphor. Then there's the most intriguing scenario, number 3, that some of these maps really do preserve traces of older geography. Not by magic, not by Atlantean satellites, but by tradition. This is where things get genuinely exciting, because we know humans can do this. Australian Aboriginal songlines encode routes, waterholes and landforms across landscapes that have changed considerably since the last glacial maximum. Polynesian navigators carried mental maps of island chains and sea swells long before they ever drew them on paper. In parts of Africa and the Arctic, oral histories preserve stories of shorelines and ice fronts from thousands of years ago, passed down as genealogies and myths. Now imagine something similar happening in the ancient Near East or South Asia. A priestly school copies and recopies a world description text for centuries. Each generation updates certain place names, maybe adds a new town or temple. But some elements are conservative. The old phrases about a great river flowing here or lands beyond the northern waters are kept for tradition's sake, even if the actual channels have since dried up, migrated or been canalized to death. Eventually, somebody in that tradition draws a schematic to go with the text. It's not a field map, it's a compilation, a greatest hits of inherited geography. Then, much later, we come along with satellite radar and realize that odd extra river on the tablet lines up, roughly, with a paleo channel we can now see under the desert. A channel that last carried serious flow 10 or 12,000 years ago. Is that coincidence? Pattern hunting? Maybe. But it's also entirely plausible that broad brush knowledge of there used to be a big river out there could survive in ritual, myth, or land lore, and then get frozen in a later diagram. On that spectrum, scenario 3 is more speculative than the map is younger and the river's just moved. But it's not wild fantasy. It's exactly the kind of deep time memory humans are demonstrably good at when their survival depends on it. And if you like these deep time stories, by the way, I go even further into them in my book. It's available at sleepytimehistory.com. And there's actually a discount running this week if you want to dive into more of this without the YouTube ads. So, which of these scenarios is correct for any given oldest map with impossible rivers? Right now, we often can't say definitively, and that's the honest answer conspiracy thumbnails never give you. We need better data, for starters, tighter dating, high precision chronologies that separate the age of the clay or parchment from the age of the inscription itself. Thermoluminescence, radiocarbon on associated materials, careful stratigraphy of where exactly the object came from. We need clearer provenance. Not this turned up in someone's collection, but this tablet was excavated in this room of this building, in this layer, with these other datable objects. Context that lets us say, with some confidence, when and by whom it was likely made. We need more fragments. Whole caches of tablets that might show intermediate forms of the same map, earlier, cruder versions alongside later, more polished copies, so we can see how the depiction evolved. Are the mysterious rivers already there in the oldest examples, or do they creep in over time? And we need independent checks from geology and remote sensing. If a line on a map allegedly matches a lost channel, we should be able to point to sediment cores, seismic profiles, or radar data that show a real corresponding feature in the ground. Not just if you squint, it's kind of similar, but the orientation, length, and junctions line up within the map's expected distortions. Put all that together, and no one can explain it stops being an incantation and turns into a research program. Instead of treating every odd line as proof that history is secretly upside down, we can sort the claims. Some will collapse into misreadings, some will remain ambiguous, and a few might, just might, turn out to be genuine echoes of rivers that disappeared long before anyone ever baked a clay tablet. Those are the cases worth getting excited about, and they lead us to a final crucial question. Given everything we've seen, the shifting channels, the symbolic diagrams, the possibilities of deep time memory, what can we actually say with confidence about the oldest maps and their vanished rivers, and what do we still have to leave in the maybe pile? Here's where we can finally separate the solid ground from the mirage. First, the part that isn't really up for debate, landscapes change. Rivers vanish, appear, and reroute themselves on timescales that overlap with human history. Paleorivers are not a fantasy. They're measurable features, buried channels in seismic profiles, old floodplains in sediment cores, sinuous ridges of sand and gravel you can trace for hundreds of kilometers with radar. We can map them, we can date when they were active, at least roughly using radiocarbon, optically stimulated luminescence, and the fossils they carry. We can watch deltas march across continental shelves as sea level rises and falls. We can see former tributaries of the Nile under the Sahara, relict branches of the Tigris and Euphrates under Iraq, ghost rivers beneath the dunes of Arabia and the Thar. So when someone says, this area used to have a big river, thousands or tens of thousands of years ago, that's not fringe. That's basic quaternary geology. Where things get shaky is the dramatic leap from that reality to a very specific claim. This particular ancient map shows this particular paleoriver as it existed 12,000 years ago. That's the weakest link. To make that jump rigorously, you'd have to lock down several moving parts at once. You'd need a securely dated map, not just roughly this period, but a tight time window for when that inscription was actually drawn. You'd need a well-characterized paleochannel, its age, orientation, branching pattern, and how confident we are that it still had surface flow at that time. You'd need to understand how the mapmaker was thinking. Is this a survey, a schematic, a cosmology? What projection conventions did they use? How did they handle scale and distortion? And then you'd need a match that survives all that scrutiny. Not just, hey, there's a line in roughly the same place, but a correspondence that holds up when you factor in map style, symbol conventions, and the normal wiggle room of ancient cartography. Right now, that last step is where most no one can explain it stories quietly collapse. They live in the gap between intriguing correlation and demonstrated identification. Between these two things look similar, and we have strong converging evidence that they're the same thing. That doesn't mean the connection is impossible. It means it's not yet shown. So what actually remains open? Whether some ancient world descriptions really do preserve blurry memories of older landscapes that go back into the very end of the last ice age. How far oral and ritual traditions can carry geographic information before it loses all contact with the original terrain. Whether a handful of specific cases, a line on a Babylonian tablet, a mysterious channel in an early Indian or Arabian text, will eventually pass the stricter tests. Better dating, clearer provenance, tighter geological matches. Those are the questions historians, archaeologists and geologists actually argue about in papers and at conferences. Not was there a secret global civilization with laser-leveled rivers, but how deep does human landscape memory really go? That's the edge of the known, and that edge is where things are genuinely fun. If you've made it this far, you're exactly the kind of person I'd love to hear from. Tell me where you're listening from and what time it is for you right now down in the comments. Are you in a river valley that's still alive, or on top of some long-dead channel without even knowing it? While you're there, if you've been enjoying this dive into vanished waterways and impossible-sounding maps, tapping like and subscribing really does help this kind of long-form, nuance-heavy content survive in the algorithm. And if you want to go even deeper into these prehistoric secrets, bottlenecks, lost coasts, drowned plains, I've put a lot more of that story into a book. You can read more about it and grab a copy at sleepytimehistory.com, because this episode is only one map in a much bigger atlas. The real question is, which forgotten landscape do you want to explore next?